Welcome to Mastering Solutions. They tell us that we're dealing with a double slit here, and this of course is a pattern for a double slit diffraction pattern. Now the challenge from this question comes from just interpreting the information from the graph. What they're telling us here is this distance to this central maximum to this central maximum is 2 centimeters. I feel like it was a little confusing in the figure how they drew it, but that's what they're saying here. So this right here is m equals 0, and then we have m is 1 and m of 2. Okay, so the delta y is from the brightest fringe to the central max, so this is really 2 delta y. But we can still use this information to figure out the information that we need. What are we trying to solve for? We're trying to solve for the distance from the slits to the screen. So that's L, of course. So that's what we need to find. And what other information did they give us in the problem? We're told that lambda is 600 nanometers. So 600 times 10 to the negative 9 meters. We're told that d, lowercase d in this case, is 0.2 millimeters, so slit spacing, 0.2 times 10 to the negative 3 meters. We're told that the delta y is, the y, delta y from here to here is 1 and here to here is 2. So let's talk about the picture now. From here to here we said is 2 centimeters. So how many sections is that? This is 1. Here to here is 2, here to here is 3, here to here is 4. So if we take 2 centimeters and divide it by 4, each of these equally spaced sections is half of a centimeter. Let's deal with here to m of 1. So we're going to say m for what we're doing is m1, and the delta y for that is 0.5 times 10 to the negative 2 meters. You could use M2 and do 1 centimeter. It would give you the same answer. And if you look at the question, and if you look at the figure, they gave us this intensity of 12. We don't need that. So they're just trying to throw you off. And even if they're not trying to throw you off, maybe they're just trying to show you a practical application of this, but some students might get thrown off and not know what to do with the 12. So what equation are we going to use for all this? We're going to use y is equal to m times lambda times L over lowercase d for the slit spacing. We're trying to solve for L, so let's multiply both sides of the equation by d. That's d over 1, of course. So y times lowercase d is equal to m lambda L, and we'll divide both sides by m lambda. So L is equal to y times d over m lambda. When we plug in our information, L is equal to y, in this case we said is 0.5 times 10 to the negative 2 meters, times the slit spacing, which we said is 0.2 times 10 to the negative 3 meters for millimeters. All of that's over m lambda, and we're using m of 1, and lambda is 600 times 10 to the negative 9 meters. So we have 0.5 times 10 to the negative 2 times 0.2 times 10 to the negative 3. That's all divided by 1 times 600 times 10 to the negative 9. So our answer for L, or the distance from the slits to the viewing screen, and that's in meters, is 1.66 meters. So let's put it in centimeters, 1, 2, and we'll round it to 170 for 2 significant figures. So we have 166.6 centimeters, or 170 centimeters rounded for our distance to the viewing screen from our double slit.